There are many scientists that proposed laws that guide how these variables change in a gas. One of those scientists is Robert Boyle. In 1662, Robert Boyle developed a gas law known as Boyle's law. Robert Boyle actually focused on three variables, and the three variables are pressure, volume, and temperature. He made an investigation. He tried to bring two similar gases at a constant temperature and tried to change the pressure. And as he was changing the pressure, he observed the volume. This is what he did. The same amount of gas is here and the same is here. And the heat input here and the heat input here are the same, meaning that temperature is constant. He tried to press this piston to obtain this. As he was adding pressure, volume was decreasing. And if this piston is raised up again from 1 to 2, volume will increase, but pressure will reduce. And Robert Boyle had to come up with a mathematical statement, which you can visualize thus. This represents decrease in volume, and this represents increase in pressure. This is a visualization of what actually happens here. When you try to press this gas, you are increasing pressure. And when you do that, what you get is a reduced volume from 2 to 1. So volume reduces from 2 to 1, while pressure increases, let's say from 1 to 2. And if you look at this, this is exactly what happens. When you try to press a gas, you are increasing the pressure. The volume occupied by the gas will automatically decrease at the same magnitude. And Robert Boyle had to come up with Boyle's law, which states that at constant temperature, the volume of a given mass of gas is inversely proportional to its pressure. Inverse there means as volume increases, pressure reduces. As volume reduces, pressure increases. That is an inverse relationship. So this inverse relationship between pressure and volume of a gas at constant temperature is what Robert Boyle investigated that led him to propounding Boyle's law. Now let us make mathematical sense from this law. According to Boyle's law, the volume of a given mass of gas is inversely proportional to its pressure, provided that temperature remains constant. What does this mean? If you plot a graph of volume against pressure, instead of getting a straight line from origin to show that volume and pressure are directly proportional, that is, if one increases, the other one increases at the same magnitude, we would rather get something like this, showing that as volume decreases, let's say this is 4, this is 3, this is 2, this is 1, and this is 0. And here we have 1, 2, 3, 4. Now, if you trace this 3 to this point, and you trace it to pressure, you see that volume is 3 there, while pressure is 2, right? From this point, if you come down to this point and trace it to volume, we get volume as 2, and if you trace down to pressure, you will get pressure as 3, meaning that volume decreases from 3 to 2, while pressure increases from 2 to 3. This is the graph of Boyle's law. You can also represent the graph this way: volume and inverse of pressure with a straight line from origin. This and this are the same, because when you say that volume is inversely proportional to pressure, it also means that volume is directly proportional to the inverse of pressure. So if this axis represents that inverse of pressure, it means volume is directly proportional to that, and you get a straight line. If volume increases, inverse of pressure will also increase. Let's check it here. Let's talk about, if this is volume, this is pressure, and we have inverse of pressure, right? Now, what is the inverse of pressure here? 1 over P, right? Pressure is 2 here, we have 1 over 2. Pressure is 3 here, we have 1 over 3. Is this an increase or decrease? Of course, half is greater than, so this is a decrease, right? If volume decreases and inverse of pressure also decreases, it means volume and inverse of pressure are directly proportional, which is the same thing as volume and pressure inversely proportional. I hope you are following. Now, I'm going to wipe this. Let us continue with this mathematics. So this is the mathematical statement. Volume is inversely proportional to the pressure. Now, let's remove proportionality sign and put equality sign. The implication is that you write constant before you now write 1 over P, right? So V will give us K times 1K divided by P. When you make this V over 1, you know, these are two fractions. You can clear the fraction by saying K times 1, which is K. P times V, which is PV. So if PV is constant, it means that K1 is equal to P1 V1. K2 is equal to P2 V2. But recall that constant does not change, right? If that is true, we can now establish that K1 and K2 are the same. If K1 is the same as K2 and K1 is P1 V1, we can now represent K1 as P1 V1 and K2 as P2 V2. And this equation is called Boyle's law. I hope you got value. If you did, click on like, share this video, follow us and subscribe to our YouTube channel. And there are many things I will reveal about Charles's law, which is coming in the next video. Follow this channel and make sure you don't miss the next video. Bye.